Hi guys, I welcome you all to my channel CSNet Lectures. So in this session, we are going to discuss about some of the important sample problems related to the top Euler graphs and Hamiltonian graphs. Okay, so in the last classes we discussed about graph theories, isn't it? So in that we saw Euler graph, Hamiltonian graphs and many type of graphs. So those graphs are very vital one. That is, vital means there are chances for you to getting questions both in MCQs and theoretical wise. So now in this session what we are going to do is we are going to see some of the graphs. Okay, we are going to discuss or see some of the graphs, and from that graph we are going to find which graph is Euler graph, which is Hamiltonian graph and so on. Right? So when you just go and work out with these types of example problems only, you will be having a clear clarification for identifying in case if they asked in examination. Okay friends, so shall we proceed for discussion? Right. So this is the given graph in your question. Okay, so in this question we are going to find, that is in this graph we are going to find whether this given graph is what type. That is, what is the type being given? It is a Euler graph or it is a Hamiltonian graph. Okay friends, another thing is that not only this one we are going to discuss, 2 or 3 graphs I am going to draw, and you must have to work out along with me, and you must have to find out whether it is this or this one, right? So now we will go for solving it. Okay, so now first tell me what is the meaning of a Euler graph and what is the meaning of a Hamiltonian graph. Okay, so suppose if you don't know, so please watch all my previous videos, there you have your explanation. Okay, so now, so what is a Euler graph? So Euler graph is used for traversing from source to destination. How we are going to travel from source to destination? We are going to travel by visiting all the edges. We are not going to leave any edges. We are going to use all the edges compulsorily in order to start from source and to reach the destination. That is the meaning. So another thing is, I have said you a shortcut for finding the Euler graph. What is it? Can you guess? So the shortcut is, instead of finding or instead of traversing all the edges from source to destination, you can use or count the degree of each and every vertices. Okay, so if the degree of each and every vertices that is being given in the graph is even. Okay, if it is even, it means that it is a Euler graph. And I also told you to remember in a short manner how Euler even. So like this you can keep it in mind. So it will be very easier for you to recall, right? So that shortcut we are using it for finding Euler graph. So now we will go for Hamiltonian graph. So what is a Hamiltonian graph? This also you can remember. Okay, just remember and see. So what is a Hamiltonian graph? So in Hamiltonian graph, we are going to travel from source to destination without considering the edges. That is, it is not needed for visiting all the edges, isn't it? So we are going to consider the vertices. We are going to visit the vertices. Instead of taking all the edges, we can choose any one of the edges. The meaning that we must have to cover all the vertices alone to reach the destination. So that is the main differentiation between Hamiltonian graph and Euler graph. So now we will go for solving it. Okay. First, let me find for Euler graph. Okay. How to find for Euler graph? So already I told you must have to calculate the total number of degrees that is being present for each and every vertices. Right? So now, so tell me what is the degree of B. So how you will calculate the degree? So that also I have explained it to you already, isn't it friends? So how to calculate the degree of B? So the total number of edges that are connected to this vertex, right? So how many number of edges are present? So if you see, it is being 2. So now calculate the degree of A. So what is the degree of A? 1, 2, 3 and 4. You have totally 4 edges that is being connected to this vertex. So now calculate the degree of C. So if we calculate the degree of C, how many number of vertices are attached with this degree? Sorry, how many number of edges are attached with this degree? 1 and 2, isn't it? So write as 2. So now calculate the degree of, let me take this one, okay. So degree of D. So now find how many number of edges that are present adjacent to that of D. So 1, 2, 3 and 4. 4, isn't it? So write as 4. So likewise, you calculate for the remaining vertices. So degree of F. So what is the degree of F? So if you take from here, you have 2 edges, isn't it? So write as 2. So now you find the degree of the remaining left out vertex, it is E. So how many number of edges are present? So it is 2. So write as 2. We have found the degree of all the vertices. So now if you just watch the values of the degree of all the vertices, it is all in the form of even numbers, isn't it? See 2, 4, 2, 4, 2, 2. So all these are even number, isn't it? Can you just able to follow? Right. So since the degree of all the vertices are coming as even number, we can surely tell that this is a Euler graph. Okay, so this graph is your Euler graph, right? So instead of traversing and seeing all the edges, whether we can reach a destination or not, it is a very tedious process, friends. So instead of that, I am just telling you a easier manner of finding it. So it is nothing but finding the degree of vertex. So if it is coming as even, so the meaning is it is a Euler graph. Suppose if any one of the vertex is being 3. Okay, if any one of the vertex while calculating, it is coming as 3, it means that it is not a Euler graph. All the values should be in even numbers. So friends, are you clear how to find whether it is a Euler or not? So now we will go for discussing whether this graph is a Hamiltonian graph, right? So friends, now we are going to discuss how to find whether this graph is a Hamiltonian graph. So shall we proceed? Right. So now for example, let me take the source value as B and the destination value as C. For example, okay. So I just want to travel from B to E. How can I do in a Hamiltonian graph? So what is a Hamiltonian graph? Just now I told you must have to visit all the vertices without leaving anyone. Okay, so we must have to use that condition in order to reach from B to E. So now we shall see how we can do it. So now let this be the starting point. I am going to traverse from B to A. So let me move like this. Please follow, friends. If you have any doubt, please give it in the comment section. I will explain it to you again. Okay. So A to C, right? Then C to D. Then D to F and then B to E. So if you just watch keenly from B to E, I have visited all the vertices. So I visited this vertices, this one and this one. So the order of traveling if you see, so from B where I have gone A, right? So from A where I have gone, so it is C. Then from C where I have gone, D. So from D it is F and F to E. This is source and this is destination. Okay, so now I can tell that this is also a Hamiltonian graph. So friends, is it easier for you to understand? Right. So now we have got a clear visualization about how to find the Euler and how to find the Hamiltonian graph. So now I am going to give you another one problem in which we can easily find whether it is a Hamiltonian graph or it is a Euler graph, right? So friends, I have given you two types of graphs. So you must have to use the same technique and rules which I mentioned you earlier just now, and you must have to identify whether the given these two graphs, among these two graphs, which is Hamiltonian and which is a Euler graph or either both, right? So I am going to solve it. So along with me, you just put your effort to solve this type of a question, right? So I am going to start with this. let me find whether it is a Hamiltonian graph. So what is the condition for Hamiltonian graph? I'll mark it like this, okay, it will be easier for you to refer. So what is the condition for a Hamiltonian graph? So the condition for Hamiltonian graph is you must have to start from one of the vertex, reach the destination vertex with the condition that all the vertices has to be visited. Okay, let me take the same vertex, that is which I took in the last problem, which is B to E. So let me start from B. Okay, let me start from B and I must have to visit all the vertices before reaching this E. Okay, so now B to A. So I can start from B to C also. It is also possible. Since I have this convenience, I am starting from B to A. You can start in any manner, friends, right? So now B to A, then from A to D, then from D to E. So if you take like this direction, if you see, C is not being visited. Okay, so shall we start with any alternative direction? Right, so let me try. I will erase this point and I will erase this also. If I take this direction, I think so I will be able to reach. So from B to A, then from A to C, right, so this is a proper path. So from C to D, then from D to E. Isn't it, friends? So what path I have chosen? So from B, where I will be writing, so B to A. Okay, so B to A, then from A to C, then from C to D, and then D to E. So if you see, in between B and E, I have visited all the in between vertices that are being present. So yes, I can tell that this is a Hamiltonian graph. Friends, are you all clear? Are you getting my point? And is it possible for you also to solve? Right. Now we will go for Euler graph. So what is a Euler graph? I must have to check the degree of each and every vertex. If it is even for all the vertices, it means that it is a Euler graph. So that we are going to find it. So let me find for A. Okay, so let me find for A. So for A, if you see, what is the degree of A? 1, 2 and 3. So starting itself it is a problem. So because degree of A, we are getting it as 3, which is not possible for Euler graph. Right? So we can stop rather than continuing to find the degree of all the vertices, because the starting itself it is coming as wrong, isn't it? So we can confidently tell that this is not a Euler graph. If you want, you can find the degree of all. Right? So now we are going to discuss whether this graph is a Hamiltonian or not by taking this path as A to B. Source is A and destination is B. So now we are going to start from A. Okay, so see whether we have visited all the vertices before reaching the destination, right? So from A to F, we can choose like this so that we can easily traverse. So F to E, E to D, D to C and then C to B. So this is the path. So if you see, we have visited all the vertices without giving importance for the edges. So I can tell that this graph is a Hamiltonian graph. Okay, I will write the order if you see. So I am going A to F, then F to E, E to D, D to C, C to B. If you see, all the vertices have been visited. Right, friends, are you all clear? So now we will go for the discussion of Euler graph for the same type. So what is a Euler graph? We are going to determine the total number of edges that is being attached with each and every vertices, that is all the vertices that are present. So now I will take this for degree of F. Let me write it here itself, okay friends. So for degree of F, what is the degree? So the degree is 2, isn't it? So for E, for the vertex E, if you see, the degree is how much? It is 3. So 3 is an odd number. So there is no need for continuing to determine the remaining edges, isn't it? Because this value is 3. So there is no possibility for this graph to be a Euler graph. So this is not a Euler graph. Right, friends? So this is a way, if they are given you many diagrams, you must have to find whether this is a Euler or Hamiltonian. Friends, I think so you will be very clear with these examples, right? So in the next video, we are going to discuss with another type of a problem. Bye.